In 1943, Kummersdorf Proving Ground, Germany. Ober-Engineer Klaus Reinhardt approaches a prisoner that will haunt him for the rest of his life. Not a man, a truck. The captured GMC sits among the spoils of war. British Shermans, Soviet T-34s, American half-tracks. Wehrmacht engineers have tested enemy equipment for 3 years. They know what to expect. Ingenious Soviet simplicity. Robust British overbuilding. Occasionally brilliant American innovation. Reinhardt circles the truck. Notepad ready. 732 to 104 horsepower. Simple construction. Almost crude. Nothing impressive. Then he removes a spark plug for routine maintenance. The threads are perfect, precisely machined. He reaches for a distributor cap from another captured GMC built in a different factory 3 months earlier. 800 meters away. It fits exactly. Every bolt from the engine interchanges with bolts from the chassis. Every measurement in neat rounded numbers. He checks a third truck, then a fourth. All identical. Not similar, identical. German vehicles require filing and adjustment even from the same production run. But these American trucks. Reinhardt requests production data from intelligence. What arrives 3 days later makes him physically ill. The numbers don't worry him. They terrify him. Because this simple truck isn't engineering excellence. It's something far more dangerous. The morning sun cut through the pine trees surrounding Kummersdorf, proving ground with that peculiar clarity that comes after spring rain. Ober-Engineer Klaus Reinhardt walked across the testing yard, his boots leaving dark prints on the damp concrete, moving past the familiar inventory of captured equipment that had accumulated since 1940. A Soviet T-34 squatted near the main garage, its sloped armor still bearing the scorch marks from whatever engagement had stopped it. 2 British Shermans sat under canvas covers, awaiting their turn for comprehensive evaluation. An American half-track occupied the space near the machine shop, its tracks already removed for detailed measurement and analysis. And then there was the truck, the GMCCCKW DeuceAndAHalf, the Americans called it. 2 1/2 tons of cargo capacity. Reinhardt had seen the initial assessment report. Captured in Tunisia, driven across the Mediterranean. As a curiosity sent to Kummersdorf because someone in Wehrmacht had. Intelligence thought it might reveal something useful about American logistics. It looked unremarkable, utilitarian. The olive drab paint was faded and chipped. Desert dust still clung to the wheel wells. The canvas cover over the cargo bed sagged slightly where moisture had collected. Reinhardt circled the vehicle slowly, the way he had learned to approach any new testing subject. Observe first, measure second, understand third. The truck sat on 6 tires, all matching 750x20. If the sidewalls were to be believed, the wheelbase looked to be about 145, and everything about the design spoke of simplicity. No exotic alloys visible. No complex mechanical systems evident from external inspection. The hood was flat and functional. The fenders were plain steel, slightly flared. Even the grille was nothing more than horizontal slats. He opened the driver's door. It swung easily on hinges that showed no sign of wear despite whatever rough handling the truck had endured in combat and capture. The interior was equally Spartan. A simple bench seat, a basic dashboard with the essential gauges, oil pressure, water temperature, fuel, amperage. The steering wheel was thin and plain. The gear shift rose from the floor, its pattern embossed on a small metal plate, 5 forward gears, 1 reverse. He climbed into the seat and reached for the ignition. The engine turned over on the first crank, not the second attempt, not the third try. After pumping the accelerator, first crank in cold morning air for a vehicle that had been sitting idle for weeks. The inline 6-cylinder motor settled into a smooth idle that Reinhardt could feel through the steering wheel and floor. He let it warm for a moment, then engaged the clutch. It moved smoothly with none of the catch-and-grab behavior that plagued even well-maintained German military vehicles. First gear engaged with a clean mechanical click. He released the parking brake and eased the truck forward. The ride quality surprised him. Military vehicles were not designed for comfort. They were designed to carry loads across terrible terrain while being maintained by soldiers who were not mechanics. Yet this truck rode smoothly across the proving ground's concrete, its suspension absorbing small irregularities without the harsh impacts he expected. He shifted through the gears. Each one engaged cleanly. Second, third, fourth was direct drive. Fifth was overdrive for highway cruising. The transmission felt precise, confident, like equipment that had been manufactured by people who knew exactly what they were doing. He drove the truck off the paved surface and onto the dirt testing track. Here was where military vehicles revealed their true nature. The GMC handled the transition without drama. The 2W wheel drive configuration meant it was not intended for extreme off-road work. That was what the Dodge WC Series and the Studebaker US6 were for. But within its design parameters, the truck performed admirably. The steering responded predictably. The engine had enough torque at low RPM to handle grades without excessive gear changing. After 20 minutes of evaluation, Reinhardt returned to the testing yard and shut off the engine. He sat in silence for a moment, considering the truck was good. Not exceptional, not brilliant, just solidly, competently good, which raised a question. Why had intelligence sent it here? What were they hoping he would find? He climbed down from the cab and walked to the front of the vehicle. Time for the detailed examination. He opened the hood. The engine bay was clean, not pristine. This was a working military vehicle, but organized, logical. Each component was accessible. The spark plugs were visible and easy to reach. The distributor cap sat where a mechanic could replace it in minutes. The air filter was a simple oil bath design that could be serviced by anyone with basic training. Reinhardt reached for his toolkit and selected a socket wrench. He would start with something simple. Remove a spark plug. Check the gap. Examine the threads. Standard procedure for engine evaluation. The plug came out smoothly. The threads were clean and precise. The gap was exactly as specified in the manual that had accompanied the truck. No 1035 in. He set the plug on a clean cloth and selected another socket. Second plug. Identical condition. Identical gap, third plug. Fourth, fifth, sixth. Every spark plug in the engine was manufactured to the same exacting standard. Not approximately the same, exactly the same. Reinhardt straightened and looked across the testing yard. Another GMC sat near the perimeter fence captured in Sicily. Arrived 2 weeks earlier. Built in a different factory according to its data plate. Pontiac, Michigan, not St. Louis, Missouri, manufactured in December of 1942, 3 months before this truck. He walked across the yard and opened that truck's hood, selected a spark plug at random, removed it, held it next to the plug from the first truck. They were identical. Not similar, identical. Same manufacturer marking, same heat range, same thread pitch, same reach, same hex size. He could have closed his eyes and been unable to tell which plug came from which truck. He walked back to the first GMC and tried an experiment that would have been pointless with German vehicles. He took the spark plug from the Sicily truck and threaded it into the Tunisia truck's engine. It fit perfectly. The threads engaged smoothly, precisely, with the exact resistance that indicated proper manufacturing tolerances. No forcing, no cross-threading, no need for careful alignment. Reinhardt's hands were not shaking. Not yet. But something cold was forming in his chest. He moved to the distributor cap, removed it, walked to the second truck, removed that distributor cap, brought them together. They were interchangeable. He tried it. The cap from the Pontiac truck fit the engine from the St. Louis truck, as if they had been manufactured as a match set. He checked the rotor. Interchangeable, the coil wire, interchangeable. Every component he tested showed the same impossible precision. He returned to his office in the testing facility's main building and sat at his desk. His notes lay open before him. He had written utilitarian nothing impressive in his initial assessment. Now he picked up his pen and added a new line. Then another, then another. The words came slowly because he was trying to understand what he had discovered. This was not just a well-made truck. This was not even just a precisely manufactured truck. This was something that should not be possible. Complete interchangeability across factories, across time, across thousands of miles of separation. He had seen German manufacturing. He had watched Opel Blitz trucks come off assembly lines at Brandenburg. Even vehicles built in the same factory on the same day required adjustment, filing, fitting. Mechanics kept files and hammers nearby because components never quite matched perfectly. It was normal. It was expected. It was the nature of manufacturing. You built to tolerances and then you adjusted during assembly. That was how things worked. Except the Americans had apparently decided that was not how things should work. They had created a system where adjustment was unnecessary, where every part from every factory fit every vehicle perfectly, where a mechanic in North Africa could salvage a part from a wrecked truck and install it in a different truck without any modification. The implications were staggering. Reinhardt reached for the intelligence request forms. He needed production data. He needed to know how many of these trucks existed. Because if the Americans could manufacture components with this level of precision at scale, then they had achieved something Germany had never attempted. something Germany might not be capable of attempting. He filled out the forms carefully, specifying exactly what information he needed: factory locations, production rates, total units manufactured, component sourcing, quality control procedures. Everything that might explain how the Americans had accomplished what German engineers had assumed was impossible. He sealed the request and sent it through channels to Wehrmacht intelligence headquarters. The response would take days, perhaps a week. He returned to the testing yard and spent the rest of the afternoon documenting every dimension, every measurement, every specification of the GMC truck. The numbers were all clean, rounded, simple: 104 horsepower, 7,532 lb, 145 in wheelbase. As if the Americans had decided that convenient numbers mattered more than optimized performance. When the sun set behind the pine trees and the spring chill returned to the air, Reinhardt locked his office and walked to his quarters. He did not sleep well that night. He kept thinking about those spark plugs, those perfect, identical, interchangeable spark plugs, and wondering what the production numbers would reveal when they arrived. The intelligence report arrived on a Thursday morning, 6 days after Reinhardt had submitted his request. The manila envelope was marked with the standard Wehrmacht classifications and routing stamps, but it was thicker than he had expected. He opened it at his desk and began reading. The first page was a summary assessment compiled from multiple sources: aerial reconnaissance over American industrial centers, captured production documents from Tunisia and Sicily, interrogations of American prisoners who had worked in automotive factories before conscription, and analyses from German intelligence officers operating in neutral countries with access to American trade publications. The numbers began simply enough. GMCCKW production commenced in February of 1941. First-year output approximately 82,000 units. Reinhardt paused and read that figure again. 82,000 trucks of one model from one manufacturer in 1 year. He continued reading. 1942 production 160,000 units. Projected 1943 production based on current factory capacity and observed output rates 190,000 units. The report noted that these figures represented only the GMCCCKW model, not including other American truck types such as the Studebaker US-6, the Chevrolet G7107, the Dodge WC series, or the Federal Motor Company's various models. He turned to the second page, which provided comparative analysis. Total German military truck production across all manufacturers for 1942, approximately 78,000 units. The Opel Blitz, Germany's most successful military truck design, had produced roughly 100 to 130,000 units since 1940. Total combined production, the entire production run. The Americans were building more of a single truck model in 1 year than Germany had built of its best design in 3 years. Reinhardt set the report down and walked to the window. Outside mechanics were performing routine maintenance on a Panzer IV. Good men, skilled men, working with equipment that was sophisticated and effective. He watched them for a moment, then returned to his desk and continued reading. The third page detailed American production methods. This section had been compiled from interrogations and captured documents, so the information was fragmentary, but certain facts emerged clearly. The GMCCCKW was being manufactured in 2 primary locations: Pontiac, Michigan, and St. Louis, Missouri. Additional component manufacturing occurred at dozens of supplier facilities across the American Midwest. The part standardization that Reinhardt had discovered was not accidental. It was the entire point of the American production system. Every component was manufactured to specifications so precise that parts from any factory fit any vehicle without modification. This allowed for several advantages that the intelligence report enumerated with clinical precision. First, simplified logistics. Replacement parts could be shipped in bulk without concern for which specific vehicle they would repair. A warehouse could stock one distributor cap design and know it would fit every GMC in the field. Second, reduced training time. Mechanics did not need to learn the quirks of individual production batches. Every truck was effectively identical. Third, faster repair times. No filing, no fitting, no adjustment. Remove the broken part, install the new part, return the vehicle to service. Fourth, economies of scale. Manufacturing millions of identical components cost less per unit than manufacturing smaller quantities of varied components. The report included a photograph slightly grainy from being copied multiple times, showing a section of the Willow Run manufacturing facility in Michigan. The caption indicated this was a bomber production line, B-24 Liberators being assembled at a rate of 1 aircraft every 63 minutes. The facility employed 42,000 workers. Most were women. Many had never worked in manufacturing before 1942. Yet they were producing 4 engine bombers with over 1 million parts per aircraft. The caption noted that the GMC truck plant in Pontiac, visible in aerial photographs adjacent to other GM facilities, appeared to be of comparable size and operated on similar principles. Reinhardt heard footsteps in the corridor outside his office. A knock on the door. He called for entry. Helpman Friedrich Fieber stepped inside and closed the door behind him. Weber was newly assigned to Kummersdorf, transferred from combat duty after the North African campaign ended in May. He was in his early 40s, lean and weathered with the careful movements of a man who had learned to conserve energy in desert heat. Weber gestured to the chair across from Reinhardt's desk. "May I?" Reinhardt nodded and Weber sat. "I heard you requested American production data. I thought you might want to hear what those numbers mean in the field." Reinhardt pushed the intelligence report across the desk. Weber glanced at the first page, then looked up. "These figures are conservative," Weber said. "I saw the convoys, Tunisia, Sicily, the final months. You could watch them for hours and never see the same vehicles twice. Identical trucks, yes, but different serial numbers, different units. They just kept coming." "Tell me what you saw," Reinhardt said. Weber leaned back in the chair. "The Americans treat vehicles differently than we do. A German unit loses a truck. It's a crisis. We strip parts from damaged vehicles, perform field expedient repairs, keep equipment running far past its design life because replacement is uncertain. The Americans." He shook his head. "They abandoned repairable vehicles. I saw it myself. A GMC with damaged axle left beside the road. Not destroyed, not booby-trapped, just left because bringing up a replacement truck was faster than repairing the damaged one." "That's wasteful," Reinhardt said. "That's abundance," Weber corrected. "They can afford to be wasteful because they have more trucks than they need, more trucks than we can destroy. At Kasserine Pass, we hit an American convoy, destroyed perhaps 20 vehicles, captured another 15. Command thought we had inflicted serious damage to their logistics. 2 days later, the same route had twice as many trucks running supplies. They simply brought up more vehicles." Reinhardt thought about the spark plugs, the interchangeable components. The system that Weber was describing made sense. Now, if every truck was identical and replacement was abundant, then repair became a simple calculation. Could this vehicle be fixed faster than a replacement could arrive? If not, abandon it and move on. The system eliminated the careful stewardship that scarcity required. German logistics operated on the assumption that every vehicle was precious. American logistics operated on the assumption that vehicles were expendable ammunition. Weber continued. "The other thing you need to understand is what this does to morale. German soldiers know our supply situation. They know trucks are scarce. They know parts are scarce. They know that if something breaks, it might not be fixed for weeks. American soldiers have the opposite experience. They break something, it's replaced immediately. They see endless convoys of supplies. They believe their industry can provide whatever they need, and they're correct." Reinhardt picked up the intelligence report again and turned to the 4th page. This section detailed component design. The GMC 270 engine was a 6-cylinder inline design with overhead valves, displacement 269.5 in. It was derived from commercial truck engines that GMC had been manufacturing since the 1930s. The transmission was a Warner T935 5-speed unit, also adapted from commercial production. The transfer case, the axles, the braking system, all of these were evolutionary developments of existing designs rather than revolutionary new equipment. The Americans had not invented new technology for this truck. They had taken proven components and refined them for mass production and reliability. "They're not trying to build the best truck," Reinhardt said half to himself. "They're trying to build the most truck," Weber nodded. "Exactly, and it works. A Tiger tank is superior to a Sherman in direct combat. But for every Tiger, they have 50 Shermans and 200 trucks to supply those Shermans. Tactical superiority becomes strategically irrelevant." Reinhardt turned to the final page of the report. It contained recommendations from the intelligence office. First recommendation: Germany should attempt to reverse engineer American standardization practices. Second recommendation: German industry should consolidate truck production around fewer models to improve efficiency. Third recommendation: Machine tool capacity should be expanded to allow for precision manufacturing at scale. Each recommendation was followed by an assessment of feasibility. The assessments were not encouraging. Reverse engineering American standardization would require retooling the entire German automotive industry. Current estimate for completion 3 to 5 years, assuming no disruption from Allied bombing. Consolidating production around fewer models would mean abandoning existing tooling and retraining workers. Cost in lost production during transition, estimated 40 to 60% reduction for 12 to 18 months. Expanding machine tool capacity required raw materials Germany did not have and time Germany did not have. The report concluded with a single sentence that Reinhardt read 3 times. American industrial capacity represents a strategic advantage that cannot be overcome through operational or tactical excellence. Weber stood to leave. There's one more thing you should know. The trucks have governors' speed limiters set at 35 mph. The Americans disable them. They drive at 60 mph or faster on supply runs. They know the engines can handle it because they trust the manufacturing quality. Our trucks don't have governors because our engines can't sustain high speeds reliably enough to need them. After Weber left, Reinhardt sat alone in his office as afternoon faded to evening. I thought about the machine tool capacity issue. Germany had good engineers, excellent engineers, but precision manufacturing at scale required more than engineering skill. It required infrastructure that took years to build. The Americans had started building that infrastructure in the 1920s and 30s, during peacetime, driven by commercial automotive competition. For General Motors, Chrysler, they had spent decades learning how to manufacture millions of vehicles with interchangeable parts, because civilian customers demanded reliability and dealers demanded simplified service. Germany had spent those same decades building craftsman traditions, specialized manufacturing, custom fitting, beautiful engineering, sophisticated engineering, but not scalable engineering. The Americans had chosen a different path, and that choice had been made 20 years before the war started. The GMC truck sitting in Kummersdorf's testing yard was not just a vehicle. It was the physical manifestation of 2 decades of industrial philosophy, and that philosophy had already won the war. Germany just didn't know it yet. By August of 1944, the mathematics had moved from abstract production figures to concrete battlefield reality. Reinhardt received intelligence reports from France with increasing frequency, each one documenting American logistics operations that should have been impossible. The Allied breakout from Normandy had occurred in late July. Within 2 weeks, American forces were operating 300 meters inland from the invasion beaches. Standard military doctrine held that such rapid advancement would create a logistics crisis. Supply lines stretched beyond sustainable capacity. Fuel shortages, ammunition shortages, the inevitable collapse that allowed defending forces to counterattack and restore their lines. Except the collapse was not happening. Instead, Wehrmacht intelligence reported something unprecedented. The Americans had established what they called the Red Ball Express. The name came from railroad terminology. Red Ball freight was priority cargo that moved on dedicated tracks with no delays. The Americans had applied this concept to truck logistics. They had designated specific routes as one-way roads reserved exclusively for supply convoys. Northbound routes carried supplies forward. Southbound routes brought empty trucks back to the beaches. No other traffic permitted, no exceptions. The intelligence summary that reached Reinhardt's desk in mid-August contained operational details compiled from multiple sources. 6,000 trucks in continuous operation, 2,500 tons of supplies delivered, daily round-trip distance approximately 300 miles, operating hours 24 hours per day. Duration. The report noted that the operation had been running continuously since August 25th with no indication of stopping. The tonnage figures were almost incomprehensible. 2,500 tons per day meant 375,000 tons per month. The entire Wehrmacht Eastern Front, spanning from the Baltic to the Black Sea, consumed approximately 15,000 tons of supplies per day, using trucks, trains, and horse-drawn transport combined. Reinhardt spread a map of France across his desk. The distance from the Normandy beaches to Paris was roughly 150 miles. American forces were now operating beyond Paris, which meant supply runs of 200 meters more each way, and round trip in trucks traveling at an average speed of, he checked the intelligence, estimates approximately 40 mph on French roads, 10 hours of driving per round trip, not counting loading and unloading time to maintain continuous delivery. The system required constant rotation of vehicles and drivers. A knock on his door. Entered without waiting for acknowledgement. Carrying a folder of documents UE captures from France, he said, dropping the folder on Reinhardt's desk. Operation orders for Red Ball Express units, maintenance schedules, driver rosters, the complete picture. Reinhardt opened the folder. The first document was a Red Ball Express operation order dated August 29, 1944. He read the daily statistics. 5,958 vehicles operational, 12,342 tons delivered, 132 different truck companies coordinated, 23,000 drivers and mechanics supporting the operation. The document noted this as a peak day, but even average days showed figures above 10,000 tons delivered. 23,000 personnel, Reinhardt said, just for one supply operation. Look at the maintenance schedules, Weber said, pointing to another document in the folder. They're rotating vehicles through service every 72 hours. Routine maintenance, oil changes, brake inspections, tire rotations. They're treating trucks like artillery pieces, firing them continuously, servicing them on schedule, replacing them when they break. The entire operation assumes that vehicles are consumable resources. Reinhardt found the maintenance document. It outlined a system where trucks were pulled from the convoy rotation in batches, serviced by mobile maintenance units, and returned to operation within 24 hours. The document specified that vehicles requiring more than 24 hours of repair should be replaced from reserve pools rather than holding up the maintenance schedule. Reserve pools. The Americans had spare trucks waiting specifically to replace vehicles under repair. The next document was a driver roster for a single truck company. It listed 273 personnel. Most were African American soldiers. The report noted this because German intelligence found it significant that the Americans were using segregated units for logistics work. What struck Reinhardt was the age distribution. 3 or 4 of the drivers were under 24 years old. Many had notations indicating they had received their commercial driver training in the Army. These were not experienced truckers. These were young men, many from rural backgrounds who'd never driven trucks before military service, now operating the most critical supply line in the European theater. They trained them in weeks, Weber said. A German logistics specialist requires months of training because he needs to understand multiple vehicle types, maintenance procedures, field expedient repairs. An American Red Ball driver needs to know how to drive one truck and how to follow a convoy. That's it. If the truck breaks, someone else fixes it or replaces it. Reinhardt turned to another captured document. This one a simplified maintenance manual. It was perhaps 100 pages, spiral-bound, with illustrated diagrams showing basic procedures. Oil change, drain plug location, filter replacement, refill capacity, tire change, jack points, plug na torque, spare tire location, electrical system, fuse locations, headlight replacement, battery service. The manual assumed no prior mechanical knowledge. It treated the truck as a closed system where certain procedures could be performed by anyone following instructions, and anything beyond those procedures should be referred to specialized mechanics. He compared this mentally to German truck maintenance documentation. The Opel Blitz manual was over 600 pages and covered multiple vehicle variants produced over several years. It assumed the mechanic understood automotive principles and could diagnose problems through observation and testing. It included detailed specifications for adjusting components, fitting parts, compensating for manufacturing variations. The American manual assumed the truck would either work correctly or not work at all, with no middle ground requiring skilled adjustment. There's something else, Weber said. He pulled out a battlefield report from a panzer unit that had engaged American supply convoys in early September. We captured several functioning GMC trucks. Our mechanics began repairing them using parts from other captured vehicles. A Chevrolet engine component fit a GMC chassis mounting point. A Dodge electrical connector worked with GMC wiring. The Americans designed their entire truck inventory with cross-compatibility. Reinhardt had not considered this. The interchangeability he had discovered within a single truck model apparently extended across different manufacturers. General Motors, Chrysler Corporation, and other American automotive companies had coordinated their military production to ensure maximum parts commonality. A battlefield mechanic working with captured American vehicles could mix and match components from multiple truck types because the entire system had been designed for interoperability. Our soldiers prefer driving captured American trucks to our own vehicles, Weber continued. The crews report better reliability, Easier maintenance, more comfortable ride quality. We have cases of German units abandoning Opel Blitz trucks in working condition to use captured GMCs instead. The implication was devastating. German soldiers, given the choice between their own nation's equipment and captured enemy equipment, chose the enemy equipment, not because American trucks were technologically superior. They were not, but because they were systematically superior, easier to operate, easier to maintain, more reliable, more available. Reinhardt found another document in the folder. This one, an intelligence assessment of American vehicle production through mid-1944. Total military trucks manufactured by the United States since 1940. Over 2 million units. Current production rate approximately 200,000 trucks per month across all manufacturers. For comparison, Germany had produced approximately 347,000 military trucks during the entire war across all manufacturers. The Americans were building more trucks every 2 months than Germany had built in 4 years. The numbers are worse than we thought, Reinhardt said. The numbers don't capture what it feels like in the field, Weber replied. You destroy an American convoy and it's replaced the next day. You capture American vehicles and they keep operating, because your mechanics can service them better than they can service your own equipment. You cut a supply route and the Americans simply build another route. There's no stopping it. There's no disrupting it. The logistics system has more capacity than we have capability to attack it. Reinhardt closed the folder and looked at the map of France still spread across his desk. The red lines marking American advance routes looked like arterial blood flow, each advance supported by thousands of trucks moving supplies forward in continuous streams. The Wehrmacht had achieved tactical victories throughout the summer. German units had fought skillfully, inflicted casualties, delayed American advances. But none of it mattered. The trucks kept coming. The supplies kept flowing. The American advance continued not because German resistance had collapsed, but because American logistics made retreat the only viable German option. There's one final detail, Weber said. He pointed to a notation in the operation order. The Red Ball Express is not the only supply operation. There are smaller convoy systems, rail operations, air transport, and coastal shipping. Red Ball is just the emergency response to the breakthrough. It's what the Americans created in a few weeks when normal supply chains could not keep pace with their own advancement. This entire system, 6,000 trucks, 23,000 personnel, 12,000 tons per day, is their improvised backup plan. Reinhardt imagined what the primary plan must look like. If Red Ball was the emergency backup, what capacity did the standard American logistics system possess? He thought about the GMC truck sitting in Kummersdorf's testing yard. That truck represented one unit in a production run that now numbered in the hundreds of thousands. A single vehicle that had traveled from Michigan or Missouri to a North African battlefield to a German testing facility, and it still ran perfectly. Multiply that reliability by 500,000 trucks. Multiply that interchangeability by millions of components. Multiply that production capacity by dozens of factories. Their was not a military force. It was an industrial avalanche that buried everything in its path through sheer accumulated mass. The comprehensive assessment reached Reinhardt's desk in late October of 1944, compiled by Wehrmacht intelligence over months of analysis. The cover memorandum warned that the enclosed data represented worst-case scenarios based on confirmed observations rather than speculative projections. Reinhardt opened the report and began reading. Within 3 pages, he understood that worst case was actually just case. There was no optimistic interpretation of these numbers. American military vehicle production from 1940 through September 1944 to 455,964 units. The report broke this down by category. Military trucks of all types, 2,400,000 units. Jeeps, 650,000 units. Half-tracks, amphibious vehicles, and specialized carriers, hundreds of thousands more. The GMCCKW alone accounted for 520,000 to 560,000 units, depending on which production records were considered most reliable. One truck, model, one manufacturer, more than the entire German military truck production across all manufacturers for the entire war. Reinhardt turned to the comparative analysis section. German military truck production from 1939 through September 1944. 347 than 490 units. Primary models Opel Blitz at approximately 130,000 units. Mercedes-Benz L3000 at roughly 80,000 units and various other manufacturers producing smaller quantities. The ratio was starkly simple. For every German military truck produced, the Americans had produced 7 trucks. In 1944 alone, American production exceeded Germany's entire war output. But the report emphasized that raw numbers told only part of the story. The next section detailed availability rates. American trucks 80 to 90% operational availability. German trucks 60% operational availability under favorable conditions, often less than 40% in combat zones, due to part shortages and maintenance delays. This meant the effective ratio was not 7.1 but closer to 10.1. An American unit with 100 trucks on inventory could expect 85 to 90 vehicles operational at any time. A German unit with 100 trucks could expect 50 to 60 operational vehicles. The strategic implications section made explicit what Reinhardt had been thinking for months. American forces could sustain vehicle losses that would German operations. Destroying 1,000 American trucks was tactically insignificant. The Americans manufactured more than 1,000 trucks every day. They could absorb those losses without any adjustment to operations. German forces losing 1,000 trucks faced immediate operational crisis. Replacement vehicles did not exist. Units would be immobilized, supply operations would collapse. The asymmetry was absolute. Reinhardt found Weber in the testing yard examining a recently captured American Studebaker US-6. "You need to read this," Reinhardt said, handing him the report. Weber flipped through the first few pages, his expression unchanging. He had seen enough battlefield reality to not be surprised by statistics anymore. "There's a Panzer Commander report in the annexes," Weber said. "I read an advanced copy. You should find it." He handed the report back and returned to examining the Studebaker's suspension system. Reinhardt went back to his office and located the annex section. The report was dated October 15, 1944, from a Tiger Battalion commander, whose name had been redacted. The assessment was clinical and devastating. "We can destroy their tanks," the report stated. "A Tiger engaging Shermans at range enjoys significant tactical advantage, but we cannot destroy their logistics. For every Tiger we field, the Americans field 50 trucks. Those trucks deliver fuel, ammunition, and replacement tanks faster than we can destroy them. Tactical superiority becomes strategically meaningless when the enemy can sustain losses indefinitely, and we cannot." The report continued with specific examples. At a recent engagement, the battalion had destroyed 17 Sherman tanks. The Americans withdrew, regrouped, and returned 12 hours later with more tanks than they had lost. German units that lost 17 tanks would need weeks to receive replacements, if replacements existed at all. The fundamental equation was unsolvable. German tanks were better. German tactics were better. German crews were more experienced. None of it mattered when the Americans could replace losses overnight and Germany could not. Reinhardt turned to the next section, which analyzed the Ardennes offensive being planned for December. The plan assumed German forces could capture American fuel supplies because German logistics could not deliver sufficient fuel for sustained armored operations. The plan required using captured American gasoline to keep German panzers advancing. The plan acknowledged that German trucks could not sustain the supply rates necessary for success. The entire operational concept was built on desperation. Attack with what you have. Sustain the attack with what you capture. Hope the enemy breaks before you run out of captured supplies. He thought about what that meant. The Wehrmacht was planning a major offensive based on the assumption that American logistics were so abundant that capturing enemy supplies was more reliable than bringing forward German supplies. The plan admitted defeat before the battle started. It admitted that German trucks could not compete with American trucks, that German supply systems could not match American supply systems, that the only path to success was stealing American success. The report included photographs taken by reconnaissance aircraft over American rear areas in France. Reinhardt studied them with a magnifying glass. Vast supply depots stretched across former agricultural fields, thousands of vehicles parked in organized rows, mountains of supplies covered with tarps, fuel tanks clustered near rail lines. The scale was difficult to comprehend. One photograph showed an estimated 400 trucks in a single depot. The caption noted this was a reserve motor pool, not a primary logistics base. 400 trucks held in reserve. Germany would consider 400 trucks enough to supply a corps. The Americans considered it a reserve pool for one sector of one front. Another photograph showed a port facility, probably Cherbourg based on the geographic features, ships unloading cargo directly onto trucks, Cranes transferring supplies from holds to waiting vehicles in continuous operations. The intelligence assessment estimated this one port was handling 8,000 tons per day. Germany's entire rail network, operating under constant Allied bombing, struggled to move 15,000 tons per day across all fronts. Reinhardt found the final assessment section. It was brief. American industrial capacity represents an insurmountable strategic advantage. Current German production cannot be increased sufficiently to achieve parity. Allied bombing campaign systematically reduces existing German capacity. No operational or tactical excellence can overcome a 10-1 material disadvantage that grows larger each month. He closed the report and sat insolence. The afternoon light slanted through his office window, illuminating dust mows in the air. Outside, mechanics were servicing a Panther tank. Good men maintaining good equipment. The Panther was an excellent tank, probably the best medium tank in the world. Germany had produced approximately 6,000 Panthers. The Americans had produced 49,000 Shermans and 2 million trucks to supply those Shermans. Weber appeared in the doorway. I thought you should know. The GMC in Bay 3 just logged its 500th hour of testing operations. Original engine, original transmission, no major repairs required. We have Opel Blitz trucks that need overhauls at 300 hours. Reinhardt nodded slowly. 500 hours of continuous operation on a vehicle that had already seen combat service before capture. The truck was still running on components manufactured in Michigan or Missouri in early 1943. Nearly 2 years of service, multiple theater transfers, capture, intensive testing, and it still ran reliably enough to pass Wehrmacht evaluation standards. There's something else, Weber said. He entered the office and closed the door. I received a letter from a colleague still in the field. His unit captured several GMC trucks last week, functioning condition. They're using them for supply runs because they're more reliable than our own vehicles. But there's the detail that matters. The serial numbers on those trucks are in the 6 million range. Reinhardt felt something cold settle in his chest. 6 million. Serial number 6423817. That's what my colleague reported. The Americans are stamping serial numbers that high because they've manufactured that many vehicles. Not just trucks. All military vehicles combined. 6 million units. Reinhardt pulled out a notebook and did the arithmetic. Million vehicles produced in approximately 4 years. That was 1.5 million vehicles per year. 125,000 vehicles per month. 4,000 vehicles per day. Every single day, Saturdays, Sundays, holidays, 4,000 military vehicles rolling off American assembly lines every 24 hours. Germany's entire war production of trucks was 347,000 units. The Americans produced that many vehicles in 3 months. We're not testing enemy equipment anymore, Reinhardt said quietly. We're documenting the weapon that defeated us. Weber said, nothing. There was nothing to say. The mathematics were absolute. The Americans had not won through tactical brilliance or technological superiority. They had won through systematic industrial capacity developed over decades of peacetime manufacturing. They had won because Henry Ford had invented the assembly line 30 years earlier, and American industry had spent those 30 years perfecting mass production. They had won because simple trucks manufactured by the hundreds of thousands beat sophisticated trucks manufactured by the tens of thousands. They had won because in modern war the system always defeats the masterpiece. Reinhardt opened his testing log and recorded the day's findings. The GMC CCKW remained operational after 500 hours of testing, all systems functioning within acceptable parameters. No significant degradation observed. He dated the entry October 28, 1944 and closed the log. Tomorrow he would continue testing. He would document specifications. He would measure tolerances. He would compile reports. But the conclusion was already written. Germany had lost the war when the first GMC rolled off the assembly line in February of 1941. Everything since then was just counting the cost. The evacuation order for Kummersdorf arrived in early April of 1945. Soviet forces were advancing from the east, and Wehrmacht facilities near Berlin were being systematically abandoned or destroyed to prevent capture. Reinhardt spent his final days at the proving ground organizing documentation, preparing equipment for transport or demolition, and ensuring that nothing of intelligence value would fall into enemy hands. The captured vehicles would be destroyed. The testing equipment would be destroyed. The buildings would be abandoned to Soviet occupation. 4 years of work reduced to ashes and empty structures. He walked through the testing yard one last time on a cool spring morning. The GMC truck still sat where it had been parked for most of its time at Kummersdorf. Mechanics had kept it operational throughout the testing period, using it occasionally for utility work around the facility when German vehicles were unavailable. The odometer now showed over 15,000 miles accumulated during capture, transport, and testing. The truck ran as smoothly as it had the first morning Reinhardt had started its engine. He climbed into the cab and sat in the driver's seat, hands on the steering wheel, looking through the windshield at the proving ground he would never see again. The German engineering philosophy had produced masterpieces. The Tiger tank was a masterpiece. Superior armor, superior firepower, superior design. Germany had built 347 Tigers, both the Tiger I and Tiger II variants combined. The Americans had built 49 and 234 Sherman tanks. Not superior tanks, just sufficient tanks, sufficient in overwhelming quantity. The same principle applied to the truck beneath him. Not the best truck, just a good enough truck. Manufactured in numbers that made best irrelevant. Reinhardt had spent months compiling a final report on American production methods completed in February before. The chaos of Germany's collapse made such work impossible. The report documented everything he had learned. The standardization that enabled interchangeability, the simplified designs that enabled rapid manufacturing, the massive machine tool investment that enabled precision at scale, the commercial automotive experience that enabled military production without extensive retooling. All of it pointed to the same conclusion. America had won the industrial preparation race during peacetime, and Germany could never catch up during wartime. The report had included a section on post-war implications that Reinhardt knew would never be read by anyone with authority to act on it. Butte had written it anyway because engineers documented truth, regardless of whether anyone listened. The American Shad demonstrated that modern warfare was decided by industrial systems rather than tactical genius. Any future conflict between industrial powers would follow the same pattern. The nation with greater production capacity, better standardization, and more efficient logistics would win regardless of individual weapon quality. The masterpiece would always lose to the mass-reduced system. He thought about the Red Ball Express. 82 days of continuous operation, 12,000 tons delivered. That was enough supplies to sustain 28 divisions for 3 months. Without those trucks, the American advance from Normandy would have stalled. With those trucks, American forces reached Germany before winter. The humble 2.5-ton truck had done more to win the war than any wonder weapon Germany had developed. No V-2 rocket, no jet fighter, no super heavy tank could match the strategic impact of 500,000 trucks, delivering supplies exactly where they were needed, exactly when they were needed. Reinhardt climbed down from the truck and walked back to his office. Weber was there organizing his own papers for evacuation. They had shared this space for months, watching Germany's defeat through intelligence reports and captured equipment assessments. Weber looked up as Reinhardt entered. "The Soviets will be here within days," Faber said. "They'll find all these American vehicles we couldn't destroy in time. They'll test them just like we did. And they'll learn the same lessons." "They already know," Reinhardt replied. Lendley delivered 152,000 American trucks to the Soviet Union. Studebaker US-6 trucks. The Soviets loved them, called them the best trucks in their inventory. After the war, they'll copy the designs, build their own versions. The Americans taught the Soviets how to build proper military logistics. Weber gathered his papers into a worn leather case. "What will you do?" "Go west," Reinhardt said. "Surrender to the Americans or British, better than Soviet capture. You the same. Though I wonder what the Americans will do with German engineers. We spent 4 years trying to understand their equipment. Maybe they'll want to understand why we couldn't match it." Reinhardt thought about this. The Americans would certainly conduct interrogations. They would want to know about German weapons development, factory locations, production methods. They would learn that Germany had chosen sophistication over standardization, quality over quantity, masterpiece over system. And they would learn that they had been correct to choose differently. The American way, simple designs, mass production, abundant supply, had been vindicated by victory. The final irony was that Germany had partially understood these principles before the war. Opel was a General Motors subsidiary. GM had brought American manufacturing methods to Germany in the 1920s and 30s. The Opel Blitz was designed using American-influenced engineering. But Germany had never fully embraced the philosophy. German tradition valued craftsmanship, Custom fitting, sophisticated engineering. These values produced beautiful machines, but not enough machines. The Americans had abandoned beautiful for abundant, and abundant had won. Reinhardt locked his office for the last time and walked out of the vehicle convoy, assembling for evacuation. He carried a single briefcase containing his personal papers and a copy of his final report. The original had been sent to Wehrmacht High Command in January, where it was probably buried in an archive or destroyed in bombing. The copy would survive as his personal record of what he had learned. That American industrial capacity was not just superior, but fundamentally different in kind. That standardization and interchangeability were more valuable than engineering excellence. That the humble GMC truck represented a greater strategic weapon than the Tiger tank. That Germany had lost the war before it started because America had spent peacetime building the industrial foundation that Germany tried to build during wartime. The convoy moved out as Soviet artillery fire became audible in the distance. Reinhardt looked back once at Kummersdorf, at the testing yards where he had spent 4 years examining captured equipment. The GMC truck would be there when the Soviets arrived. They would test it just as he had tested it. They would measure it, evaluate it, document it, and they would reach the same conclusions. That modern war was won by logistics. That logistics required standardization. That standardization required industrial investment. That industrial investment required decades of peacetime preparation. The Americans had understood this. The Germans had not. The difference was measured in millions of trucks, billions of tons of supplies, and the distance between Detroit and Berlin. Years later, in 1953, Reinhardt would be interviewed by American military historians studying German wartime assessments of Allied equipment. He would tell them about testing the GMC truck, about discovering the perfect interchangeability of parts, about reading the production figures and understanding what they meant. The interviewer would ask if German engineering could have matched American production given time and resources. Reinhardt would answer honestly, German engineering had produced masterpieces. American engineering had produced systems. Modern war needed systems. The masterpiece could not compete with the system because the system could absorb losses, sustain operations, and replace itself faster than the enemy could destroy it. That was not a failure of German engineering. It was a success of American philosophy. They had built trucks that were good enough, manufactured them in overwhelming numbers, and won the war through arithmetic rather than artistry. The GMCCCKW would serve in American military inventory until 1956, 21 years of service from a truck, designed in 36 hours of urgent planning in 1941. Some would continue operating in foreign military service into the 1990s. The simplest American truck would outlast the most sophisticated German tank by decades, not because it was better engineered, but because it was better conceived. Good enough at impossible scale had defeated perfect in limited quantities. The humble truck had won the war, and every nation that learned this lesson would shape their military production accordingly. The age of the masterpiece had ended. The age of the system had begun, and it had begun in a Michigan factory in February of 1941, when the first GMC rolled off the assembly line.